Okay, so we are now on session 4 out of 6. So this session's all about our file servers. Let's go back to the slide. Next week we're going to look at GitHub and Git and show you how to do repositories and do version control. And then the week after, I'm going to show you some shell scripting, but I'm trying to figure out how much depth to go into because there's whole books on shell scripting. It's a massive subject, and I don't want to scare you off too much. But the good thing is the last session won't affect the assignment, will it? Remember the week 6 is just extra information for you. So I'm going to show you some shell scripting. I think I know what I'm going to show you, but I might go into a bit more depth or less depth depending on how we feel. But we're going to talk today about file servers because up till now, to get files on your web server and your database server, you had to wget, didn't you? Get the files across from another server. What we're going to talk about today is FTP and Smb, the two main protocols that allow you to transfer files to and from your server. Okay, so at the end of the day, you can add this functionality to your web server. So you can use CyberDuck or FileZilla and transfer files across using FileZilla, and you can create network drives and mount those network drives on your computer. So you can literally drag files straight across on the desktop. FTP, it's easy to talk about it and try and describe it. FTP, if you remember, is an application level protocol. Remember we had that diagram last week showing all the different protocols, just like HTTP. So FTP is another high level protocol which sits on top of TCP, remember, which deals with packets and checksums and making sure the data's arrived, which sits on top of the IP system. So the idea is FTP allows you to transfer files to and from devices. And to be honest, it's dead easy. There is one package you have to install to get this to work. And the package is called VS-FTPD, which stands for Very Secure FTP Daemon. Okay? And the reason it's called Very Secure is because it uses SFTP. When you install it, you don't connect using FTP, which is unsecure and not encrypted. You connect using FTP over Secure Shell. And you know about Secure Shell, don't you? You've used it all the time to connect to the server, where you have that public-private key encryption between the client and the server. So by installing this, you're going to run the FTP session, which isn't secure, over an SSH session, which is secure. So it gives you that extra level of security. In other words, exactly the same way that we connect to Creative. Remember, you connect using SHTP, SFTP even. Okay. It's Benedicta, she's electric. And and basically, as you can see from the package size, it's such a lightweight protocol. It's less than half a meg to get a complete secure FTP system set up on your Raspberry Pi. Now, as with all packages, there's a config. Okay, as with all packages, there's a config file, and the config is the vsftpd.conf. And let's just show you a little example of how this looks. Okay, we'll talk to this in more detail, line by line, but I'll very quickly go through this. Well, so you can have what's called anonymous FTP. If you want anyone to be able to download files from your server, you can set up an anonymous server, so you don't have to log into it, basically. So it's always very important to make sure that you set that to no. Otherwise, anyone can log into your system without having to put a password in or username. We'll ignore that for a minute. Write enabled is the obvious thing. If you say no, it becomes read-only. So if you want people to just get files off your server, you can say anonymous enable yes, write enabled no. And that gives people anonymous access to just read and download your files. Okay? We'll talk about this in a bit more detail later on. This is basically, when you drag files on, file open mode 750, basically that's permissions that are set on any files that you try and retrieve from the server. So if you drag files off the server, they'll have that permission set. Okay, does that make sense? So the person who drags them off gets full permission, the group they're a member of gets read and execute, and no one else can access them. This is all about what happens to files when you drag them onto the server, and I'll explain how this works, how an unmask works. Okay. Local users basically means you can have individual FTP accounts. You know how when you've got, everyone can log in and use their own FTP? Excuse me. Right, there. Well, that one. Interfering. I'll move that out of the way. Okay, let's try now. Okay, so, and this is all about where the local routes are. Right, basically, you know how on Creative you've got when you log in, you go into your home folder. Well, this is the path to your home folder. Now, we can't upgrade Creative without breaking it, because with the current version of the VSFTPD, you're not allowed to set the home folder as the landing page for security reasons. So what I've suggested here is we specify the root folder where you connect to as being the public HTML folder. So $user represents the user's folder. That makes sense? And then we're saying that when you land, you'll land in the public _HTML folder when you FTP in. Obviously it has to exist for it to work. Okay, now, other useful command. If you ever make changes to that configuration file, you've got to restart the FTP service. You can restart your whole server, or you can restart the FTP daemon, and that will restart the FTP server. Now, this is the trick of it. It took me ages to get my head around this. When you drag files onto the server, they've already got permissions set, haven't they? They'll already have certain permissions assigned to them, certain chmod settings. Now, basically, the file open mode is a mask of settings which are applied to the file. These are the additions, the extra permissions added to it. The umask is permissions taken away from the file. So if the file had a certain set of permissions, you can add extra permissions to make sure it's going to work on the server, but you can remove permissions from it to make it more secure. Do I have an example of this? There you are, look. So permission example, if I set the file open mode to 750, it will add those flags to the permissions, the 750 flags. That makes sense? If I set local unmask to 027, if those flags are set, it'll remove them. So if I drag a file onto the server which everyone has full permissions, it will basically remove permissions from everybody else. So it's really important you understand this, because obviously when you drag files onto the server, you want to make sure the permissions are set according to the rules you define. So this is what gets added to the permissions, and this is what gets taken off. It's a mask of permissions removed from the files. So you can decide, so if you look at this one for example, you can see I've kind of matched up the columns, look. So I've basically said I want RWX for the owner, I don't want W, but I want X for the group, and I want nothing for everybody else. So you can define those permissions. If you don't define those permissions, the files are uploaded with the permissions they had originally, which is unknown, isn't it? If you're dragging from a Windows computer, it's all unknown. You have no idea what those permissions are set to. So it's very important you get the file open mode and the local unmask set up properly according to your system. And all you have to do to test it is just connect using, this is CyberDuck. You can use FileZilla. Remember to use SFTP because it's done over secure shell. The URL is the server is the IP address, isn't it? There's my username, which is a bit unsafe because I'm using root, and port 22, which is the SFTP port, and that's it. Now, I didn't spend long on that one because there really is not much to talk about when it comes to FTP. It's really quick. Once you get used to this, you can set up an FTP server in 10 minutes. on a Linux server. Set up and configure the server. The important bits, the bits which take a bit of figuring out, is the file open mode and UMask, and deciding on what the local routes are going to be. In other words, when the user logs in, where they're going to end up. Where's the default folder? And I say, we used to be able to put /home/$user with nothing at the end, but the last version of this software, they've prevented that now. And that's why we're going to have to rebuild Creative over the summer, because if we upgrade it, it's going to break everyone's FTP access, isn't it? They'll end up in the wrong folder. So FTP is really simple to set up, which is more than we can say for SMB. SMB is a little bit more complicated. So in other words, you should very quickly be able to set up an FTP server and drag files onto your server. To set up an SMB server, it's a bit more complicated. SMB stands for Server Message Block, and basically it allows you to share files, printers and ports. So it's not just for file sharing. You can SMB, the manual SMB is about this thick, and basically you can set up your Raspberry Pi as a print server. So you could take your Raspberry Pi to the side of your printer, plug it into the USB slot, and build yourself a wireless printer or a network printer quite easily. So there's loads of stuff you can do with it. You can have ports, so you can actually have it. So you can have a set of some serial ports connected up, and then connect those through the network to another computer. Okay. When I say serial, also serial includes USB, so you can actually have remote USB ports on your computer by using SMB. Really powerful protocol. And you connect to the servers using something called Netbios, which we'll talk about over TCP/IP. So Netbios is another application level protocol. Okay, so Netbios is like FTP, like HTTP. It's a high level protocol. And then the idea is you send commands, which are called SMBs, to the server, and it works just like HTTP. It's a request response system. So you send a request for something, whether it's a printer, a file share, a serial port, and it responds with the data. And let's have a look at some more detail. Now you must have come across Netbios names. You know, when your Windows computer, when you've got networks shares, and you've got these capital names on these servers. You know, sort of the names of the machines that you connect to on your network. They're Netbios names, and that's what is used by SMB. So in other words, you've got to make sure that your device has a Netbios name. And by default, if you install it on the Raspberry Pi, I think it's set to Raspberry Pi. So it's nice and easy. So it'll appear on your network as the server called Raspberry Pi. And we can change that if we wish to. Now, workgroups. You come across workgroups and domains. Okay, do you understand the difference between the two? Okay, the idea is a domain is a set of servers where you've got central access control. So the university is a domain because it has a central login, an Active Directory server to log into everything. If each server has its own login systems, handles its own logins, it's called a workgroup. So a domain is where the authentication is handled in one place for lots of servers. A workgroup is where each server handles its own login. And what's really cool about SMB, you can configure your Raspberry Pi to be an Active Directory server. So you know how you've got these Windows login systems at the university where you have a domain, username and password? That could sit on a Linux server. It's just a protocol. You can set up primary domain servers, you can set up backup domain servers, all on Linux. So you've got this domain controller, and normally when you log into Active Directory, it's a Windows server sitting there, but you could technically turn your Raspberry Pi into a central domain server to control your whole network at home. Connect logins to your computers, access to printers and drives. You could do everything that's at the university on the Pi because it's just using the protocol. Now, important thing about SMB and Windows. SMB is built right into Windows. It's part of Windows. It's not a separate service you install afterwards. So unlike Linux, where you install SMB as a separate application, every version of Windows has its own implementation of SMB, which is good. The problem is each version of Windows has a slightly different implementation of SMB. So if you configure it on, say, an XP machine, it'll be different configuration from, say, a Server 2008, Windows Server 2008. But they've all got their own slightly different implementations, but they all support SMB out of the box. Right, so we get on to Samba. You can kind of see why it's called Samba, can't you? Yes? Basically it's a free SMB server. And this is actually available, but it's not for Windows. So if you want to have a consistent experience across all your devices, you can technically install Samba on Windows if you wanted to. But Samba is mainly aimed at Unix variants, Unix servers, Linux servers. Okay? And basically it's an open source project. It's developed by this guy Andrew Tidgell, okay, and it's developed by a huge team all over the world. And basically it allows your Linux computer to pretend to be a Windows computer in simple terms when it comes to networking. So in other words, when you set up Samba on your Raspberry Pi, it's indistinguishable from a Windows server on the network. It looks exactly the same, has the same features, same functionality. It's just a very small one. If you go to someone like Warwick University, they have their entire system, even though you've got Windows clients connecting to it, their entire backend system is Linux. Their primary domain servers, their backup domain servers, their file servers, everything is based on Linux. And they're massive users of SMB and they contribute to the project. So it shows that it's quite a heavily used system. All right, Netbios names. It's important that every device on your network has a Netbios name. And basically, if you look at the configuration files on your Raspberry Pi, you'll see it's defined in the configuration file. So if you want to change the name, you simply change the configuration file and restart the service. So you can change the name of your device from Raspberry Pi to anything you want. And obviously, if you're going to have lots of servers on the same network, they've all got to have different names. So you've got to make sure that you change the Netbios name for every single device, so it's different. Right, there's two applications to install for this one. The first one is the server. Okay, and technically you could just have the server installed, but normally I tend to install the client. And that means not only is your device able to be an SMB server, but you can connect to other SMB servers from the Raspberry Pi. So you can create this sort of network of servers. And as you can see, not massive files, are they, to get it installed and configured. Now, as usual, this is kind of like a broken record, isn't it? Every package you install has a configuration file. And this is no exception. This configuration file is smb.conf. How are you getting on with your configuration files, by the way? How are you coping with them? Are you getting used to the idea of just configuring the file? Once you've done that, you go back to, say, a Windows or a Mac system, and you've got these screens and tabs and things, and you actually think it's really clunky. Just having this simple configuration file is I find much easier. So the configuration file is big. Just like the Apache configuration file, most of it is comments. And if you read through the configuration file of any of these packages you install, it actually explains really clearly of how it all works. And right at the end we have shares. Okay. Now, the Netbios name. This got me fooled for some time. This confused me, because you would think the Netbios name would be in the Samba configuration file, wouldn't you? Because Samba's the application that needs it. It's not. It's actually located in two different files. And the amount of time I spent traipsing through the system, the folders, trying to find out how it worked is untrue. Basically, there's a file called etc hostname, and there's a file called etc hosts. Now, etc hostname is the name of this server, of the server you're working on. The etc hosts lists the names of all the devices that server is going to talk to, which includes itself. So if you change it in the host name and don't bother changing hosts, it can't see itself. Don't worry, I've been there, couldn't figure out what's going on. You've got to change it in both locations. So you've got to change the host name of the device, and then you've got to tell the device that its host name has changed. Okay, and literally, I'm not even going to put a slide of what you do. Literally, the file just says Raspberry Pi in both files. That's it. All you've got to do is change Raspberry Pi to whatever server name you want. And then you have to restart the service. Now the service is both the Smb service but also the network. Because the host name is a network setting, isn't it? It's to do with the network. You've got to restart both services. So what I just do is restart the whole server once I've changed it, and that just sets everything in place. Here we are. This is a configuration file. If you go right to the end of the Smb file and ignore all the other settings, this is the important bit. There's a configuration, there's a drive called homes. That bit there is the name of the drive. That makes sense? That's the network share. This is all exactly as default, apart from that little bit there. That's the only bit I've had to change in this particular share. So, most of it should make sense. Home directories comment. You know when you look at your network shares, they've got little messages under them, describe them. Browsable notes basically means if you're not logged in, if you're not allowed to access the share and edit the share, can you see the contents? So do you have read access to them? So if you're not logged into the server, what I'm saying is if you're not logged in, you can't even see the share. It's not even visible to you. Think about your network shares at the university. If you're not logged in, you can't even see the share, you can't even see the drive, can you? As soon as you're logged in, the drive appears, the network drive appears. Well, that's what that's doing. Read only, it's kind of a neat fail-safe. By default, you can't write to no one can write to their shares. Just in case, I suppose, if you switch it on and don't configure it properly. You have to explicitly flick the switch for people to be able to write to their shares. Create mask basically says, if someone creates a file or drags a file onto the server, what permissions should it have? So if I go onto my network share and create a new HTML file, what should the permissions be set to? And if I create a directory on the server, what should the directory permissions be set to? And the default one, can you see the default one is actually really secure? The default permissions are the person who created the directory can do everything to it, and no one else can do anything. But obviously, if this is a folder on your web server, you have to change that, otherwise it won't run. And valid users, %s basically means everyone with an account. Everyone who has a valid account on the server can be a user. Oops, that's gone a bit small. Okay, a couple of extra useful features. Can you see that one? Sorry, I forgot to make the font big. There's also a force group and force username. So when you drag a file onto it, or create a file, or create a folder, you can specify what the username, which user should own it, and which group should own it. So you can control as files get added. And this one is nice. Veto files basically says, are there certain file extensions you do not want to upload? For example, if you don't want people sharing music, you might put veto on .mp3 and .wav. What I've suggested is, for the sake of any Windows devices connected to it, I don't want any exe files, or any .com files, or any .dlls, or any .bats, or any .sql files. And if I try and drag one of those files onto the drive letter, it will just bounce back. It won't allow me to drag the file on, so you can control this. Right. So this is an example of creating another share. So what I'm doing here is let's go back a few slides. That one. This one, okay, the homes is a special one because every person who logs onto the server has their own home. They don't share the same folder. Now, what I'm going to do here is create another share, and this share is going to point to my web root, my Apache home folder, if you like. So you'd have to add this yourself if you wanted it. So I've defined the name of my share, the name that appears when I connect to it from my desktop computer. I put my comment in. I specify the path I want to point to on the server. I specify it's browsable. I specify read-only. And there's another one there you might want to put in there. I might add to this to the slide. At the moment, any Samba user can access this share. You can restrict it, okay? You can tell it only certain users. You can have another directory called valid users. Does that make sense? Then you list the usernames that can connect to that particular share. That would be rather useful. I'm going to add that afterwards. Now, because if you get this wrong and you restart the service and no one can access their shares, there's a little test program. If you just run test palm, it will actually read through your Samba configuration file and check for any errors. That makes sense? It'll make sure there's no mistakes. Because obviously, if you restart it and it's wrong, you've locked everyone out from their shares. No one can access their network drives. So the best thing to do is to run test palm to check that everything's okay before you apply the changes and restart. Service Samba restart, and we've restarted the server. Now, basically, this is what the test palm looks like, just to give you an idea. And you can see it's going through, look, each of the different drives. Look, so we've got, there's a potential print there, a print service. There's my printers configured. There's my home folders. There's my web root. Load this service file's okay. That means everything's fine. That line there means it's a work group setting and not a domain. Does that make sense? So that reminds you that the server is part of a work group and the server is not part of a domain. If it was part of a domain, that would change. Okay? And when you go to your computer, that's on my Mac, that's what I see when I connect to my Raspberry Pi. I think the icon's a sort of tongue-in-cheek joke about Windows. So basically, as you can see, look, under shared, there's my network, there's my server, and when I go in there, you can see that there's my web root. Because I didn't specify that the web root was restricted, I can see it. Because remember I said I didn't say browsable equals no, did I, in my configuration file? So it's visible just there. If you want to completely hide it, you just say browsable equals no in your configuration file, and then by default there'll be nothing displayed. I can log in, connect as, because it's a work group. When I logged in, I'll see my home folder, my web root, and be able to access both of them. So fundamentally what you've got is a file server. You've got a network server which you can drag and drop files onto. You can mount network drives. So on the Windows machine, you would choose that web root and you would say, make that my R drive or my W drive. Make sense? If anyone does this and can give me some slides, some screenshots, I'll stick them in the presentation. The challenge. Connect from Windows, do me a few screenshots of it on the white background, and I'll add the slides to the presentation. It's just I have no Windows computers to test this from at all. So as you can see, really simple to set up a Samba server, an Smb server. Now, any existing user can be given access to Samba, but by default they don't have access. Okay, so think about this for a minute. All existing users on your Linux server may be given permission to access Samba, but you have to explicitly give them permissions. And what you do, you have to assign them a Samba password. Remember you had the password, didn't you, to change your password? There's another command called Smb password. And as soon as you assign them a password for Smb, they can log in and connect to these shares. There we are, look. So to change the test users, to allow test user access to Smb, I'll type my Smb password, okay, and the name of the user. And I can now assign them a password, and from that point they can log on to the server and they can connect. My login screen, sorry. Is it okay? Start it again? Okay, so as you can see, I choose registered user, I put my username and password in, connect, and look, once I've connected, there's my web root, and look, there's my, not only is it mounted the file, the home folder, it's assigned the correct username to the home folder. Okay, so does that make sense? You can connect, so you can create you can install Samba, you can configure it, you can add users to it, you can create shares, create drives on Samba, and then it looks just like any other Windows file server. Right, another useful thing for security, no idea why it's PDB edit, but basically what you're doing is you can list any Samba users on your server. So if you want to do a quick audit of who's got access to Samba, that allows you to list all the Samba users. Okay. All that slide. Okay, and that's it. Now, why did I put the command in there? Okay, I'll come back to that one. I'll have to figure out the command for that one. Basically, what I'm saying on that one is you can list all the shares. Look, can you see I've got print, web root. You can see the work group I'm a member of. You can see the name of the server, the comment, the name of the. You see what I mean? But for the life of me, I can't remember what command I use for that one. So I'll have to come back and add the slide to it. So as you can see, the building a file server is slightly more involved than building an FTP server, but it's well within your capabilities to build a nice simple file server. And once you've done that, I encourage you to experiment further and to play around with print servers, for instance. Because technically you could turn your home printer into a network printer for the cost of a Raspberry Pi. Yep, so I encourage you to play around with this stuff. The great thing about open source software is it's free as in beer and free as in speech. Do you know what I mean by that? Do you understand the difference between free as in beer and free as in speech? There's two meanings of the word free. Free as in beer, as in it doesn't cost you anything to buy, and free as in speech, as you can change it, you can express yourself, make changes, and do what you want to it. So open source software has a lot of advantages. Now, what I want to do is talk to you now about what we're going to be doing next week. What we're going to be doing next week is Git. We're going to be working on content versioning systems. And what you're going to be doing is you're going to be working with a system called GitHub initially. Have anyone done versioning before? Bit. Versioning? Version control? Now, the great thing about version control is it serves several purposes. It allows you to keep incremental backups of your work. So anyone had any problems where they've made lots of changes and it's broken? And they have to find an old zip copy and unzip it and reinstall it and everything else. Once you learn how to use versioning systems, that will never happen again. Every time you make changes, you commit to the changes with a note to explain what you've done, and at any point you can roll back to an earlier version and start with an earlier version. The other advantage of it is you can work together on the same project. So you can have one central storage, you can both check out copies of the code, you can both make changes independently of each other, and it'll merge everything back together into a final product. Now the Git software we're going to be using was invented by a guy called Linus Torvalds, who also may have invented something called Linux. And he wrote Git because the existing version systems didn't scale properly and they didn't do the job he wanted. Git will scale to an unlimited number of users on the same project. You can have tens of thousands of people editing the same project and everything still works. So what we're going to do next week, we're going to create a master repository on the GitHub, which is a cloud-based system, and you're then going to clone that repository onto your Raspberry Pis, and you're going to work on the Raspberry Pis and then commit changes back to the server. So I'm going to show you the whole of the process, the pull-push process. So I've asked everyone to make sure you've set up yourself a GitHub account before next week's lecture. That'd be really handy. Okay, so we can really sort of hit the ground running on this. Anyone use Xcode for anything? at all. Well, software like Xcode and Eclipse has Git support built in, so you can actually look at your changes and commit your changes from inside your IDE. So there's lots of different tools that you can use that have Git support built into them. I'll leave the fun for next week to show you how cool it is. But is anyone working on group projects, team projects this year? Or is everyone just, you are? Speak to me about it, and I can set you up a group repository, a private repository on GitHub for that. I've managed to wangle 125 private repositories for free off them. I just had a nice talk to them and explain what we're using it for. Normally it should cost us about $400 a month for that, but we managed to get that for free for the university. So that's my triumph for this last week. But even if you don't use these ones, you're entitled to have unlimited public repositories on GitHub for free. Anyone seen GitHub? Anyone tried to download anything from GitHub? Yeah? So have you tried cloning, or you just download zip files?
We've done a small amount of collaboration.
Brilliant. How do you get on with it?
It was confusing initially, but once you get the hang of it.
Yeah, the concepts are difficult. So for next week's presentation, I've got some cool diagrams to kind of show you what's going on with it. But once you've done this, you'll never ever go back to emailing zip files to each other for projects. Who's doing 321com? Oh, guys, talk to me. I can set you up repositories for this, so you can share your code. Yeah, share your code, share your work. Yeah. So talk to me about it. Give me the names of the set up Git accounts. Email me a list of your Git users and the name of your project, and I'll set you up a shared repository so you can share your 321 project work. Yeah, do it for real. Okay. Anything else? I spoke to a few people. Anyone else having problems with their labs for this particular task? I know, Tim, you're having problems. Anyone else having problems with getting this assignment finished off? Anyone going to get less than 90% on this? I hope not. I mean, my expectations for this assignment are very high. Yeah, he seems to be getting on really well with it. I can tell this because I walked past the Monday lab and there's absolute silence. It's like there's no one there. I see Julian's head bobbing up and down occasionally. But apart from that, everyone seems to be getting on with the work. And Wednesday, I don't know, Wednesday lab seems to be going really well as well, doesn't it? Everyone's just getting on with the task. Yeah.
Like to get 5 here, how can you make it professional? It's like code.
Sorry?
Like to get 5, like mark.
Yes.
How would you get it? Like, don't you get like professional, but how would you make something like this?
How would you get the highest grades?
Yeah.
Well, to get, okay, do you want me to very quickly go through the assessment again, do the five marks, and just kind of explain what they're about? Because I think sometimes we lose track of what they mean. 2 out of 5 is a pass, isn't it? That's 40%. So if you have a go at things and just kind of scrape by and do the bare minimum, you're going to get 2 out of 5. If you complete all the tasks, the 4 tasks that are listed, you're going to get 3 out of 5. Okay, that's simple. To get 4 out of 5, you've got to take things further. You've got to do your own work. You've got to look at the extension tasks and have a go at the extension tasks. We need to see evidence that you're taking things a lot further. You're trying things out. And to complete the extension task with no problems at all, to a professional standard, and that's the key word here, professional standard is a 5. In other words, I look at what you've done, I look at what a professional would do with the same setup, and they're indistinguishable. That's where you get a 5. So when you did the client, the jQuery mobile client, if your final result was indistinguishable from, say, something like Facebook web app, yeah, or the Twitter client, that's where you get the 5. Does that make sense? A 5 is 100%. Has anyone ever got 100% in their module marks before? I rest my case. So everyone's saying, "Oh, I only got 4 for that. I didn't get 5." You only got 80% for this assignment. Yeah, 80%. Yeah, it's very rare people get 80%, isn't it? So don't be disappointed if you get 3 out of 5. That's 60%. That's the 2-1, isn't it? That's the bottom end of a 2-1. 3 out of 5. Because the numbers are tiny numbers, people get disheartened about this. 2 is a pass, 3 is bottom end of 2-1, 4 is a first class, and 5 is perfect. Okay, so don't. I've created off my own back on this one by having the marking system with small numbers in, isn't it? If I'd said 20, 40, 60, 80, 100, there'd probably be less people whinging about it, wouldn't there? But if you think about it, it's the same thing. 1, 2, 3, 4, 5 is 20, 40, 60, 80, 100. It's just big jumps between them. I did that because I didn't want to get in a situation where they say, someone, he got 42 and I only got 41%. Yeah? Or he got 47, I got 48%. Yeah? If you stick to those, if you look at the descriptions of those five marks, okay, 3 is a very respectable mark for any of these tasks. It means you've completed the tasks. You've got a 2-1 for it. To get the 4s and 5s, it has to be extension work, a lot more work, and then for the 5, exceptional work. Absolute exceptional work for a 5. It says a lot that even with these tight rules, there's still some people who've got 5s. In fact, there's 2 people who've got 25 out of 25 for the last assignment, but only 2. So please do your best. The last assignment is going to be formative, the one on the cloud, which means you don't have to do it, but I encourage you to have a go at it. We'll give you some feedback on it so you know where you've gone wrong and what you've done right or wrong. So I can give you your final marks in about 5 weeks' time. You get your final module grade in 5 weeks. No, sorry, 7 weeks, isn't it? Because I gave you a 2-week extension. I need time to mark it as well. Yeah, assuming I can do the marking instantaneously, it'll be 5 weeks, wouldn't it? 7 weeks with allowing time for marking. So well before Easter, you'll know what your final grade is. Okay, which should help you a little bit and start to bump up your averages a bit. Because I'm looking at the grade profiles and some cracking grades coming on. In fact, I'm going to have to argue with Christina on some of these because some of them are so high. Yeah, they're going to get queried by the board. But everything's been moderated and the high grades are justified. Okay, so well done. All you need now is to get 40 out of 40, 40% for this one, 25 out of 25 for this one. Think you can do it? Yes, maybe? Or close? Okay, thanks. You've actually done a fantastic job in this module. You've done me proud, so thank you for that. If you want to come and annoy some second years at Harper's 1 this afternoon, come and see me after this lecture, and we'll have some strategies. Okay, thanks very much.